Hi, today we will be solving Leetcode problem number 5, longest palindromic substring. So for solving this, let's first know what's a palindromic string. So the definition of palindromic string is any string which when read forward or when read backward, it sounds the same. Not just sound, its alphabets are same. For example, ABA, if you read it this way, it's ABA. When you read it this way, it's ABA. That means it's a palindromic string. Same with ABBA. When you read it this way, it's also ABBA. So it's also a palindromic string. Same with this one, but this is not a palindromic string. As you can see, when you read it this way, it's ABCA. But when you're reading this way, it's ACBA. So it's different. So I hope you have understood what a palindromic string is. A palindromic string is which can be read same from left to right or from right to left alphabetically. Now, the question is we be given some strings. Let's say B A D. Now, in this given string, we have to find the longest possible substring, which is a palindrome. Okay. For example, here, if you see B, if you just take B is also a palindrome. As if you read it this way, it's B. If you read it this way, it's B. So it's also a palindrome, but its length is one. Is BA a palindrome? No. Is BAB a palindrome? Yes, with length 3. So for currently our answer is BAB. Correct. If we see BABA, it's not a palindrome. If BABAD, it's not a palindrome. Okay. If we start from A, we see ABA is the longest palindrome. If we start from B, the longest palindrome will be only B. If we start from A, the longest possible palindrome will be A. If we start from D, the longest palindrome will be D. So we had two possible answers, two longest possible palindromes present in this string, BAB and ABA. Correct, as when both read backward or forward are same, respectively. So our answer can be BAB or our answer can be ABA. Here the answer is BAB. As it says, ABA is also a valid answer. As you have seen, the most intuitive thought to do this problem was to start from every number and then check the palindrome. Start from every number, then check the palindrome. So what we are doing? We are trying to find every possible substring, correct, which will take us n square. As we start from every character and we go till everyone. So n minus 1. This gives us a complexity of n square. And this can be done easily because it's the constant here are 1000 only. So we can easily use this approach to find every substring and then check whether it's a palindrome or not. Okay, but the problem is for every substring we are taking n, and for checking whether it's a palindrome or not, we are taking another n. Here we were doing it verbally, it's ABA, but when we need to check it, we need to make it go through another n operations. Correct. Let's say I found a substring ABA. Now I need to check it. So I need to check the whole string. So it's going to take n times, which is n cube. Correct. So this will take 10 to the power 9, which is not allowed. So the point is still same. We need to find every possible substring, but we have to find it such a way, in such a fashion. See, the problem is going to be get solved in n square only by finding every substring. But we need to find it such a way that we need not to apply another n operations to check whether it's substring a palindrome or not. Okay, and how can we do that? See, if I start from here and then go further to the next, what do you say, the next character to add into my substring, this will cause me a problem as this way I am reading BA, but I don't know how I am going to read it in reverse. For that, I need to use a reverse function which is going to take order of n time, and then I have to compare them. Okay, so that's a bad approach. That's n cube. What we are going to do, we are going to expand from a place. Expand. Okay, so let's say I am at B. What I'll do, B is a substring of this. Any substring with length 1 is a palindrome. It's like totally obvious to you guys. Okay, so after taking a character, we will expand both the ways. As that way, we have to only check character present here and here. If these two are same, then it's a palindrome, otherwise not. Correct. If you are taking any palindrome number, and you are starting from its middle, okay, every number present on its edges at same distance will have to be same. For example, if it's B, if it's A, it has to be A. If it's a palindrome, correct. If it's C, this also has to be C. Otherwise, it can't be a palindrome. Correct. So that's the approach that we are going to use here. First of all, let's say we are at B. We will check A and this character. If there is no character, we will break. We will break out of a loop. So here we find the maximum length as 1. Correct. Now we will check for A. While checking for A, our maximum length is 1. Now we will expand. So we will check for this and this. If these two are same, that means the length of substring which contains A will get increased by 2, and its starting index will be this. Earlier, the starting index was this 1. Now, since I have added both these numbers, the starting index will be 0. Okay, starting index will be 0, and the length will be previous length plus 2. Obviously, we are adding two elements. Now we will check for this index and this index. As this index is not present, we will break out of it. Okay, this way we have found a substring with length 3. Correct. Now let's start from B. If we start from B, our length is 1, maximum length, and the starting index is 2. Now we will check we will expand, we will check A. Both are same. This and this is same. How we are going to do this? We are going to make a for loop which start from 2, and left side it minus, in right side it plus, until either this minus value is 0 or this plus value is less than equals to n minus 1. Correct. So both are same, so the length will be increased by 2 and the index will be minus by 1, the start index of the new substring. It's here, right? We check for B and D. These are not same. So we will break out of a loop with these values. Length 3, index 1. Length 3, index 1. This is the approach. This is the whole approach. Now, there is another case, which is you might have a substring palindrome which is common from base. What I mean to say is something like this: B A B B A B. Like, if the number is odd, the length of palindrome is odd, then there is no problem. You can start from 1. But what if the number of palindrome is even? So we have to take two numbers. So previously that was case 1. We have to check for case 1 also, and this is case 2. So what we are going to do, let's say in a for loop, we come to this index I. We will check whether I is equals to I plus 1. The character present at I is equals to I plus 1. If it's present at I plus 1, we are going to take, previously we were going to take length as 1. This time we are going to take length as 2. Rest everything is same. We will expand simply. Length will be increased by 2, and the index will be subtracted by 1. Simple. That's it. We need to write just two cases. First of all, for single, for odd, and for even separately. We can even combine these two, but if I'm going to like give you the approach for combining these two, you might get confused that why it's working. But I'll also explain it at the end. So currently we will write a code with two separate approaches. Okay. So let's get to the code. So first of all, as we need to give the maximum length, so we will take the global start index and global max index, and then we will start from the starting of the array, whichever given to you, and then we will start with a local length and local start index. Okay. Now this is the test case. This is the code for the case for odd palindromes. Correct. Here we will start from number I. Okay, and then we will go further. We will go. We will keep on checking it that it's working or not working. Okay. So why j is one? Why j is one? So j is one is trying to say here is, let's say, my I. First of all, there is a loop I iterating over I. 0, 1, 2, 3, 4. Let's say, first of all, I am at 0. So what I want to do? I want to do minus 1. I want to check minus 1 and plus 1 of the 0. So that's what happening. I have taken j. I have taken j minus 1 and j plus 1. So that way it will be minus 1 plus 1, then minus 2 plus 2. So I will be checking this index, then this index. You're getting me? Correct? So that's why I have taken j is equals to 1. So I'll check j minus 1 is equals to I plus j. If both are same, so what I'm doing, I am adding 2 to my local length and subtracting 1 from my local start. That's what I told you. Why we are doing that? Correct. We are doing minus 1. If we are I am at a, I am doing minus 1 for index and plus 2 for length. Okay. And if this is not true, if I minus character at I minus j is not equals to character at I plus j, then I'll just break. Then I will check, is my local length greater than my maximum length? If yes, I will just change the values. Maximum length will become local length, and start index, global start index will become local start index. Okay. Now the second situation, which I told you, that we need to see if my this is same as this, the next. Okay. So that I can consider the starting length as 2. Okay, for the even test cases. So in that way, this is the code for even tests, even palindromes. Okay, so I'm checking whether s of I is equals to s of I plus 1. In that case, there is no change in the code. It just local length is equals to 2. That's it. Rest everything is same. Everything. Local length is getting increased by 2. Local start is decreasing by minus 1. Simple. That's it. And here, since we are checking a number which is I plus 1, so that's why it's I plus 1 plus j. You can write it this way: I plus 1 plus j. Like previously, the number was only I, only I. Let's say I'm taking a number here. Wait a minute. Sorry. Let's say I'm taking a number only present here. Correct. If it this is I, so this is I minus 1. This is I plus 1. Correct. But this time I'm taking two numbers, this and this. So this is I and this is I plus 1. So this is I minus 1 and this is I plus 1 plus 1. Getting me? So this is why it's I plus 1. This is the only changes in the code. First is local length is 2 and I plus 1 here. That's it. Here it was just I. And you know the reason why. Similarly, we will check again if its local length is greater than max length, then we will change the values. Here we have updated the values again, local length to start index I. Correct. At the end, we will give the substring starting from start index with a length of max length. Correct. Let's try the code. 12 ms. It's a good code. Now, as I told you that we can combine both these cases together also. How we are going to do that? What we are going to do, while in our first loop, this loop, I loop, we will check if my next integer is same, if my next character is same. See, let's say if I am here, I will check this. If let's say this will also be, I will check this. Okay. I will keep on checking until my characters are same. B, B, let's say there it was A. I will keep on checking. Then I will initialize my length with these number 1, 2, 3, 4, 5. I will initialize with it with 5, and then I will just keep on the same algorithm. I will check for A, I'll check for this characters. Okay. That's the only difference. In starting, when I am checking I plus 1, I will keep on checking until my these characters are same, and then I'll expand, and I will start my len value with the total number of these same values. I hope you can code it on your own as you have got the code, got the concept. And if you have any doubt, please do let me know in comment section. I will solve it for you. And if you want me to do code for this also, just write down in the comment section, and I will give you code in the comment section only. Thanks.